Doing problem 102, binary tree level order traversal. It's a pretty good tree problem. Given the root of a tree, return the level order traversal. So left to right, level by level. So for this example, it returns a list of lists where each list is the level and all of the nodes from left to right in that level. So 3, then 9, 20 on the second level, 15, 7 on the third level. If this 9 had any children, let's say like a 1 or a something else, that would also go in this last list, right, in the output. So maybe an example, this is terrible, I'm not going to do that actually. I hope that actually just makes sense. But the second example is if there's just a root, then you return just a list where the only item is another list and it's just the root value. So the approach that we're going to take for this problem is use a queue, because you want to go, you want to go left to right in order, right? So to maintain the order of things, queues are good, first in, first out, and we're just going to use the size of the queue to basically control the inner loop, and the outer loop is going to be while the queue is just not empty. I'll go ahead and show the approach for that, but we're basically just going to be going in order, and you have to be careful about when you add things to the queue and when you pop things off the queue. But let's talk about it right now. So result is just an empty list. That's what we're going to return. Let's do some error checking. If root is null, let's just return the result because it's an empty list, right? Let's create our queue. It's just going to be an empty list in Python, and then let's add our first item, which is just the root, into the queue. Now let's go into the outer loop. While the length of the queue is greater than 0, let's get the size of the queue, and let's create this current level. And what this current level is going to be is it's going to represent all of the nodes at the current level that we're at. That was a mouthful. So current level would, if we go level by level, imagine it this way. First it'll be 3, and then when it finishes, we append that to the result. Then this will get created again after the loop finishes. The current level will be 9 and 20, get appended to the result, gets created again as an empty list, and then 15, 7 gets appended to the result, so on and so forth for every level. So for I in range of the size, and it's important to get the size here because the length of the queue is going to constantly be changing, right? It depends how many items actually live at that level that you're traversing. So for I in range size, we're just going to grab the actual node. We're going to pop off from the queue. Pop off. And what we're going to do now is we're popping off the front to maintain that queue-like structure. We're going to add this to the current level, right? Current level.append node.value, because you don't want to actually append the node. You just want to put the integer value in there. And so once you've appended that node, now you can check if it has any children. So if node.left, then we're going to append node.left into the queue. You do the same thing for node.right. Queue.append node.right. And then after that should be it. Once this inner for loop finishes, just append to the result, the current level. And then when this finishes, just return the result. That should work, I think. Great. Nice. So the time and space complexity for this problem, let's talk about it. Space complexity, you're maintaining a queue that you're constantly popping off from, and it's changing over time. So that's actually interesting. You create an empty queue. You don't keep up the entirety of the tree all the time, but in the worst case, let's see, get to the bottom. You keep up the actual the entirety of the tree, I'm pretty sure. So space complexity, it's O of n. And then time complexity, it's also just O of n because you're going through every single node. So yeah, cool. I'll do more tree problems like this one. I think they're pretty good until I get a job, and then I can stop making these videos. Okay, thank you. Bye.